So our second day of algebra review here in geometry, we are going to talk about radicals. So these are something you are going to use, maybe not till a little bit later on this year, but definitely something we learned last year that you are going to be using a ton this year. So we're going to remember how to simplify radicals, add, subtract, multiply, divide, all of that good stuff with radicals. So hopefully this will be come back to you fairly quickly, but we're going to start with the basics, right? So if I have the number 1 here, 3 radical 100. So remember, the radical is like a square root. So that means that you're thinking what times itself equals 100, right? That's what a square root of 100 means. What times itself equals 100. Now, in this case, 100 is a perfect square, right? We know that 10 times 10 equals 100. So the square root of 100 would equal 10. Now, we're kicking it up right away. If all I had was the square root of 100, then my answer would be 10. But I have 3 radical 100, which means that they're asking us to do 3 times the square root of 100, right? When they're just written next to each other, that means times. So 3 times the square root of 100 is really 3 times 10. And then 3 times 10 would be 30. Okay, so that's the idea, right? Now 100 was a perfect square. But if I look over here at number 2, I have 9 radical 48. 48, that's not a perfect square. And we spent an entire unit last year in 930 talking about what do we do with these radicals that aren't perfect squares. And what we talked about was that we want to take that number, that whatever it is, and break it into its factors, where one of those factors is a perfect square. Right? So I want to figure out what multiplies together to give 48, where one of those things is a perfect square. So I'm sure the first thing jumping out in your head is probably 4 times 12, right? The square root of 4 times the square root of 12 would give me the square root of 48. That's true, but 12 also has some perfect square factors. So you could go this way and then keep working on that square root of 12, right? Or you could and say, okay, well, square root of 12, what multiplies together to give 12? 4 times 3. So I have square root of 4 times the square root of 3. And now I've gotten all the way down, right? Or you could take it and really try to find the factors of 48 with the biggest perfect square. So I know that 16 times 3 also equals 48, and the square root of 16 is a perfect square, and it's a bigger perfect square, right? And I get to my answer much, much faster. So really, what you want to do is try to find the biggest perfect square factor that you possibly can. I'll show you how these both work out. I'm going to start with the easier one over here on the right, because now I say, okay, well, the square root of 16, that's 4. I'm going to bring this 9 down out front, right, because this is really 9 times the square root of 48. So I'll have 9 times 4, but then the square root of 3 is not a perfect square, so it has to stay as the square root of 3. It can't change at all, right? Now I have 9 times 4 out in front. If I have those two numbers out in front, I'm multiplying them together. 9 times 4 gives me 36. So I have 36 radical 3 as my final answer. Now, if I look over here on this longer way that I started with, the one that probably jumped out at you first, I see that I have the square root of 4 is a perfect square from this one, right? So I'll bring down my 9. That first square root of 4 in the blue is going to turn into a 2. And then I'm going to have another square root of 4 here, which is also going to turn into a 2. But this square root of 3 at the end here, that's not a perfect square, so it stays how it is, right? And I'm only looking at the ends of my branches here. The 12 has changed to a radical 4 and a radical 3, so the only one I have left here is the square root of 3. And then I could do the same thing and multiply all these together. 9 times 2 is 18. 18 times 2 is 36. So I end up with the same answer, but finding that biggest perfect square possible is definitely easier. It saves you time and it's much less confusing. So really look for those biggest perfect square factors that you can. All right, so that was a review of just simplifying, but you know, in this class, we're not just going to give you a number and ask you to simplify it. It's going to be mixed in with other things. Sometimes you might have to add or subtract these radicals. So remember, for adding and subtracting radicals, okay, adding and subtracting, just like adding and subtracting with fractions, you need to have like radicals. And like radicals means that they have the same number, oops, there we go, inside the radical, okay? So it doesn't matter what number is out in front, they have to have the same number on the inside of the radical to add or subtract. So if I look at this, I have negative radical 6, minus radical 54, minus 2 radical 2, minus radical 18. If I look at those numbers inside, 6, 54, 2, and 18, none of them are like radicals, so I couldn't combine any of those right now. However, I do know that a few of those could be simplified, right? Now the square root of 6, this is really, the factors of 6 are square root of 3 and the square root of 2. Neither one of those is a perfect square, so I can't do anything with that, so I don't need to break that one at all. So radical 6 just stays how it is. However, square root of 54, this could be the square root of 9 times the square root of 6, and 9 is a perfect square. Square root of 2 on the next one, no factors of that is a perfect square. 2 is not a perfect square, so nothing can do there. But the square root of 18, that I can do. This becomes the square root of 9 and the square root of 2. All right, so let's see. I'm going to bring down my negative 2 radical 6. That's not changing. I'm going to bring down my negative sign, right? But now I have the square root of 9, which becomes 3. Radical 6 can't do anything, so it's saying how it is. So that second term became minus 3 radical 6 instead of radical 54. I'm going to bring down my minus 2 radical 2. I couldn't do anything with that. I'm going to bring down my negative, and now I've got the square root of 9. Again, it's 3. Square root of 2 I can't do anything with, so it's staying radical 2. So now that last term became minus 3 radical 2. All right, now I'm going to go through and look at these. Oops, sorry about the bell. So here I have a radical 6 and a radical 6, so those two I'll be able to combine. Over here I have a radical 2 and a radical 2, so those two I'll be able to combine. Now, these radicals, once you get like radicals, work just like variables, right? If I said I have negative 2x minus 3x, I would get negative 5x, right? The x doesn't change, just like the radical doesn't change once you start adding, okay? When adding or subtracting, the radical does not change. That's why they have to have the same radical, because if they didn't have the same radical, you wouldn't know which one to keep. Okay, so once you're actually adding and subtracting, you're just looking at the numbers in front, and you combine those, whatever operation it tells you, and then the radical doesn't change. So now I could do negative 2 radical 2 minus 3 radical 2 would also give me negative 5 radical 2. So I have negative 5 radical 6 minus 5 radical 2, and you could definitely put those in whatever order you wanted to. You could have the negative 5 radical 2 first, and then the negative 5 radical 6. Just be careful that your negatives line up with the terms that you want. Okay, so adding and subtracting, you have to have like radicals, which means you got to simplify those radicals first. Multiplying is a different story, though. When I'm multiplying, just like with fractions too, I don't have to have like radicals. I don't have to have like denominators. They don't have to be like terms. Okay, so multiplying and dividing, do not need like radicals, okay? What you're going to do instead, which we've actually been doing while we've been simplifying, is we take the outside numbers and multiply those together. So we do outsides with outsides. Sorry, I knew that was going to happen. Move this over a little bit, sorry, give myself a little more room to write. Okay, outsides with outsides, so 3 times 2 would give me 6, and the answer goes on the outside. Then I do insides with insides. So 6 times 10 would give me 60, and that needs to stay on the inside, okay? So outsides with outsides stays outside, insides with insides stays inside. And this works for both multiplying and dividing, both, okay? Now, I'm not done, though, because I see the square root of 60, and I know that there's got to be some perfect square factors of 60. So let's see. 12 times 5 I know is 60, but neither one of those are perfect squares. Let's see, how about 4 times, oops, lost my pens here. 4 times 15, square root of 4 times the square root of 15. There we go. So the 6 is going to come down in the front, right? Just like we talked about on that first slide. Square root of 4 is a perfect square, so that's going to become 2. So they're both outside, so they're just going to be multiplied together. Square root of 15, though, the only factors of 15 are 5 and 3. Neither one of them is a perfect square, so it's going to stay as the square root of 15. So my last step now will be doing a little bit more multiplying. Oops, there we go. And I do those outsides with outsides again. 6 times 2 is 12. Radical 15 as my final answer here. Okay. If you could have simplified the radicals at the beginning, you know, the square root of 6 or the square root of 10, you could simplify first and then multiply if you wanted to. Neither one of those could have been simplified, so I couldn't have done that one. But be careful, even if you simplify first before you multiply, you might have to simplify again after you multiply. So it's up to you, but just make sure that you're checking before you say you have your final answer that that radical can't be simplified anymore. All right, so here's another way to look at multiplying, right, is distributing. So it's the same process, outsides with outsides, insides with insides, but you're doing it more than once, right? So first thing we're going to do is we're going to multiply the square root of 15 times 4 radical 2. So take this whole term, multiply it by this whole term, right? Now, square root of 15 doesn't really have anything on the outside, so it's really like 1 radical 15 if you want to think about it. So we say, okay, outsides times outsides, 1 times 4 gives me 4. Insides with insides, square root of 15 times the square root of 2, again, sorry about the bell, 15 times 2 is 30, that's going to stay on the inside, right? Okay, I've done that distributing. Now I'm going to distribute to the next one. So I have the square root of 15 times the square root of 6. So those are the next ones that I'm doing, right? Square root of 15 times the square root of 6. Now again, square root of 6 doesn't really have an outside, so you could kind of ignore it, or you could think of it as a 1, right? 1 times 1 gives me 1, but so I'll be positive, and then I would do insides with insides. Square root of 15 times the square root of 6, so 15 times 6 gives me 60 plus 30 would give me 90, right? Okay, so that's the idea. You just have to really be careful of what's on the outside, what's on the inside, right? Outsides with outsides, insides with insides. You're just doing 2 separate multiplying. So if you wanted to think about it, and maybe I'll scooch this down a little bit. If it really hurts your brain to see what I did, really what I did was square root of 15 times 4 radical 2, right? Or 1 square root of 15 times 4 radical 2. And then I did radical 15 times radical 6. Those were the 2 distributing I did that got me to my answer of 4 radical 30, right? Plus radical 90. Now I'm still not quite done. I got to make sure that I simplify whenever I can. Let's see, square root of 30, that would be 6 times 5, 2 times 15. None of those are perfect squares, okay? 3 times 10, nope, none of them. And square root of 90, let's see, that one I know for sure because there's definitely a factor of 9 in there. So I have the square root of 9 times the square root of 10, and 10 can't be simplified anymore. So my first one is going to stay put. It's going to stay as 4 radical 30. My second one, the square root of 9, is going to become 3, And then the square root of 10 can't be simplified, so that second one becomes 3 radical 10. 4 radical 30 plus 3 radical 10. Notice I'm adding now, so I can't combine them because they are two different radicals. So that's what my answer will look like. Okay. All right, so the last thing that we have to do then is we have to talk about dividing. So just like with multiplying, insides with insides, outsides with outsides, same thing with dividing, right? We can divide our insides with our insides, or we can divide outsides with outsides. So the first thing that I always look for is pretend if I have both inside, right, or both outside, pretend that radical is not there, and could I simplify the fraction, right? 3 over 18, I can simplify that. What I would do is divide both of them by 3. You always want to do that with radicals as well. Just make sure that you're doing insides with insides, right? And outsides with outsides. And outsides with outsides. So since I don't have anything outside here, I'm just looking at the insides, but I can still do the same thing. I can say divide by 3 on both of them. Just remember, insides with insides, it stays inside, right? So this will become the square root of 1 over the square root of 6. All right. Now, the next thing that I would do, is I would look for any perfect squares. The square root of 1 is one of those that hides in plain sight, right? What is the square root of 1? What times itself equals 1? Well, it's 1, right? So this would equal 1 over radical 6. Okay. Now you might think that we're done, but hopefully some warning bells are going off that you are remembering something from last year, and that is that you can never leave a radical on the bottom of the fraction. Never leave a radical on the bottom, right? In order to clear that radical, you need to multiply the top and bottom by that radical. Okay, what I mean is I can't square it because that would change the value of my fraction. Instead, if I multiply the top and the bottom by the same thing, that's like multiplying by 1, right? Radical 6 over radical 6 is 1. So I can multiply the top and the bottom by the same thing, and what I want to multiply by is that radical on the bottom, right? So if I really think about this, okay, the square root of 6 times the square root of 6 down here at the bottom, this is going to become the square root of 36. What is the square root of 36? The square root of 36 is 6. So on the bottom, I'm going to get 6. Now remember, multiplying a radical times itself. Square root of 6 times the square root of 6. It's like squaring a square root, right? The radical is going to cancel out. So you don't have to show this step that I just put underneath. If you are good knowing that a radical by itself equals just the number inside, you don't have to show that square root of 36 step. If that is something that you have a hard time with and you just like to think inside times inside and then simplify, perfectly fine and show that square root of 36 step, right? Whatever works for you is fine. Okay, on the top, 1 times radical 6 is just radical 6. So this is what we'd want our answer to look like. Never have a radical on the bottom. Clear that radical by multiplying the top and the bottom by that radical on the bottom, and that will clear it out. Just remember outsides times outsides, insides with insides. All right, guys, we just reviewed everything you're going to need for this year. So remember, for simplifying, find that hidden perfect square. That's one of the factors, right? Try to find the biggest one to save yourself time. When you're adding or subtracting, you must have like radicals, so simplify before you add or subtract. If you're multiplying or dividing, you don't have to have like radicals, insides with insides, outsides with outsides. All right, and then if you are dividing, rationalize that denominator. That's what that's called when you clear that radical off the bottom. So you multiply the top and the bottom by the radical that's on the bottom. Hopefully you are remembering all of this now.